Dun dun dun. Da, 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 dun, 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 Whoa, 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 whoa. That was quick. Okay. Um, my desk is so messed up. I'm trying to lift. Okay. Yeah. Hello. Welcome back to our daily stream. Studying data structures and algorithms. I am your host. Okay. So there were a few weird questions I saw, and I've, taken them and tried to stream with that today. Yesterday, I covered. So basically, throughout this week, I've been doing stacks questions, right? Sorry, queues. Oh my god, how did I forget? Maybe I was in the queue. Nice. Okay. Um, please don't mess up today. My internet, please. I beg you. My internet, please, please. I beg. I beg you to be good to me. Okay, my internet is back up and running. So, hello, Comfort. Comfort has always been coming to this stream. Our Comfort. Hmm, interesting. Anyways, welcome. I hope you learn one or two things from this session today. Is it one or two? Well, I'm going to talk about a lot of things. Anyways, I'm just delaying a bit before I get started because I usually like at least two or three people to be in the in the chat before I mean watching before I get started with the question. Hello, Ransom. Ransom is here again. Nice. Nice to have you. Okay. All right, all right, all right. Comfort says, I don't know who Comfort is, but I think Comfort is excited to learn. Good. We shall see. I hope to meet. Anyways, let's get started. I think I have. Okay, there are three people currently watching. Good, good, good. Let's get to. No, it's yeah, three people. Okay, now I think I can get started now. I've had enough people in this stream, so yes, I will start now. Okay, so let me read the question. This question is implement stack using queues. I'm not sure why anyone would want to do that, but I this was a really I think this is a strange choice to make. I actually chose this question because of the way people responded in the description. Anyways, enough of that. Let's jump into the question. So implement a list in. Calm down. So all right, let me take this out of my view so that I'll be able to read the questions. Implement a last in, first out, LIFO, right? Stack using only two queues. Using only two queues, okay. The implemented stack should support all the functions of a normal stack, right? We have push, top, pop, empty. Okay. So implement the my stack class, right? So my stack class is given to us as an input. So I tried doing some things here, but anyways, we'll get back to that. So the push does not return anything, so it is void. Pushes an element X to the top of the stack. To the top of the stack. Pop. Pop removes an element on the top of the stack and returns it. So it returns an integer. Top also returns an integer. It returns an integer. It returns the element on the top of the stack. Okay. So empty will return a boolean, so which is going to return true if the stack is empty or false otherwise. Note: you must use only standard operations of queue, which means that only push to back, pick or pop from front, size and is empty operations are valid. Depending on your language, the queue may not be supported natively. You may simulate a queue using a list or deck, right? Double-ended queue, as long as you use only a queue standard operation. Okay, so I started, trying to implement this. Let me reset this again. Yes, confirm. So this is the normal input we are giving. So we are giving a my stack class, and we are to implement every method in this class here, or yeah, all of the methods here. We will do that. That's basically the task we are giving. So here is an example. We have a my stack, so an instance of a my stack class will be created, which returns an empty array, an empty list. Push will push a value on top of the stack. Push again will push a second value. Top will return the top value on the stack, so top is supposed to return the value. Okay, so here are the inputs. Okay, so top will return 2. Okay, pop will return 2 as well, which is good, and empty will be false. Is empty not true here? So let's see. At most, the constraints are x will be less or equal to 1, less or equal to 9. At most, 100 calls will be made to push, pop, top, and empty. Okay, all the calls to pop and top are valid. Okay, I was reading this question ahead of this stream, and I think I understood it to some extent, but as you can see, I provided a solution before, and that solution didn't go as I was expecting it to. But anyways, let's see how we can solve this question. We are given a class, my stack, with a few methods in the class for us to implement. So the first one is going to be a constructor function. Basically, when we create an instance of this class, right, what gets returned, right, what is created at that point in time, which is everything that will be adding in this init function here. Okay, so let's see what is next. So pushes element X to the top of the stack. Pushes element X to the top of the stack. Now, a stack is a data structure that supports a first in, last out operation. Meanwhile, in this case, they are asking us to, implement a last in, first out, right? So the last item to be added to the stack is the first to be removed. So let's see on the board here. I'll quickly erase this. Let's say we have our stack like this. Um, you know, we'll represent it with an array. Ideally, a stack is simply an array of values, right? So we'll put 1, 2, 3, right? Now, normally, right, the last item to be added in a stack is the top item in the stack, right? But in this case, they are asking us to, conduct a LIFO operation. So the last item to be added to the stack will be the first to be removed. In other words, the last item added to the stack will be the item at the top of the stack, right? So it's not going to be our conventional first in, right? First out. Sorry, first in. So stack, when we add an item to the top in a stack, it is the last item to be added to the stack. So last in and first out, right? Is that the same thing we're asking here? Last in, first out. Oh, wait, what am I saying? Hold on. Seems I'm confusing myself. Normally, so I used to represent stacks like this. So I'll add 2, 3, and 1. Sorry, 1, 2, 3, right? So 3 was the last item to be added in the stack. So 3 will be the first item, the item at the top of the stack, right? So when we want to remove, we pop like this and so on, right? But so this question is asking us to do exactly that. Okay, I think maybe I was thinking about queues directly. With queues, right, you do something like this. So the first item in the queue, 1, 2, 3, will be the first item to be removed, right? Will be the item at the top of the queue. So in a normal word, in a normal day-to-day queue, the first person in the queue was the first person to arrive in the queue, right? So that person becomes the top of the queue. Instead, in the case of stacks, the last item added to the stack is the item at the top of the stack. So, which is what we want to implement using every functions in a queue, right? So there is a deck method in Python from the collections module that we can use, which is this. Otherwise, if we're using a different language, we would have to implement the queue ourselves, right? So here's what I did. I started solving this question. Like I said, let me create a file for this. This will be leet225, my stack. So I'll create it in the queues class. So let's see. Oh my god, where has this gone? Okay. So let's create some. I'll erase everything here. I was trying to solve the question, but I didn't finish it. So let me just remove everything I have here so I can start from scratch. All right. Let me save this like that. Okay, you know what? Let me remove this. Come on. Save. So I'll put this file in queues. So let's create a queues file. So this will be leet dash what number of question is this? 220, right? 225. Okay. 225 stack. Okay, 225 stack with queues. Okay, so let's run. I'll copy this and place it here. All right, so we are given some methods to use, which is nice, right? So yesterday I talked about the the deck. Hold on. Okay, we can bring it back. Yesterday I talked about the deck method on the collections module, which we can use to have access to every queues related functions. So I'll quickly demonstrate that. So we can do something like this. Say from collections import deck, right? So we have the deck here, and I'll create a new deck. So I'll say, let me first of all create a list of numbers. I'll call this nums like this, and say this will be, sorry, this is going to be 1 2 3 4. Okay, 4 like this. And we can do something like this. We say my deck, I'll call this my deck, is equal to, okay, let's call this my queue, because we are talking about queues and we are going to use decks to create the queues. So this will simply be deck and deck of nums, right? So let's print this out to see what this has. So we can say print my deck, my queue, sorry. Let's run this. Now you can see we created the queue using the deck method from the collections module. Now, what's so special about this? Well, there are some functions that have been created on this deck deck method, which we can use. Is this a class? I think this is a deck class. Yes. Okay. So this deck class from the collections module. Sorry if I have been saying the wrong thing. So we can use this deck class, right? We can have access to some methods on the deck class which are not, available to us in normal list functions. So we can say, let's say my deck, I want to print the I want to remove the first element from the deck, right? So we can say my queue dot pop left, right? If I do pop left, it will remove the first item from our deck, right? So I'm still referring to nums as our array, but actually our nums, our queue is different from this nums here. I'm just leveraging the values in nums to create the queue, right? So this is what we'll have. So instead of having something like this, we'll have 2 3 4. So let's print that. Now you can see we have 2 3 4. Meanwhile, in the case of lists, right, if we want to remove the first item in the list, we'll have to use the pop method and pass the index at which we want to remove the item, right? So again, that is still possible, but there are a lot more use cases for deck that will be easier for us to use than to use list, right? So let's go ahead and continue with this. So first of all, we'll create a deck. So I'll close that. We'll create a deck. I'll say this will be self.queue. We'll create a queue, sorry, a queue. Self.queue should be equal to a new deck, right? So say deck. Okay, I need to import this from the collections module. So from collections, import deck. So we can use the deck here. We can use the deck here and set it to an empty deck. So this will create an empty queue, right? And basically the queue is a list of empty numbers. So an empty list. Sorry, that was wrong. Okay, so now we want to push an item to our queue, right? So we push. So what does it say? Push an element to the top of the stack. To the top of the stack. Last in is first out. So the last item will be the first to be removed, right? Okay, so let's do it this way. Now, I've been having an issue with this, but I'll just continue like I'll just implement it the way I did before. So we can say self dot q, right? Self dot q dot append x, right? Now when we push an item to the queue, we don't return anything, right? You can see it is void here, so which is good. So we don't return anything. Now for pop, to pop an item means to remove the element on the top of the stack and return it. So remove the element on the top of the stack and return it. So we'll say return self dot q dot pop, right? Like I said, pop here will return. So we are returning. If we did pop like this, right? Hold on. Pop left is different from pop like this. So we are removing the last item from this queue here. This is a bit confusing, right? Because we want to implement stack with a queue. This is not. If we pop like this, right, it means we are removing the last item from the queue. Instead, if we do something like this, pop left, right, it means we are removing the first item from the queue. So if this is the first item in the queue, so we are referring to the first item as the top of the stack, right? So meaning if we want to push an item to the top of the stack, in this case, we are just adding to the end of the stack. So what do we do now? We will have to add the item in front instead of, the end of the queue, right? So let's see, is there any way to add, is there any built-in function for this? Append doesn't take, it only takes a value, index, start, stop, clear, extend left. What does extend left do? Extend left, I mean, we know extend left will, normal extend, will spread a list of values into an array. So let's see, extend left. I'll put like 3 here. So extend left 3. So what would this do? Oh, you can see it adds 3 to the front of the list. Okay, we can use this instead. So I'll do this. I'll use this instead. So instead of using append, I'll say extend left the value x, right? So okay, this is good. I'm not saying, there's a way we can do this with normal arrays, right? We can iterate through the array, and you know what, let's try that. Let's try to add an item in front of the array using in front of our list. I always say arrays, I don't know why. Anyways, we understand what arrays are, right? So it's also called list in Python. So we can iterate through every value, right? Well, first of all, append the value and then iterate through every value in the array and then append it behind, right? So let's try that. So how do we add an item in front of an array in Python or a list in Python? Now this is just an experiment I'm trying. So we can say for I in range, so we can iterate for every value. First of all, we'll need to append the value, right? So I'll say append nums dot append 5, right? So we added 5 to the array, right? And we want this 5, right? This append to do something special for us. You know what? Let me do it this way. I'll define the function. So let's define append to top, right? So we can take a nums. You know what? Let's just use this nums like this. Just say the value, right? So this value will be an integer. So I'll just put int like this. Let's go. So what we need to do is we'll first of all append the value to nums, right? So nums dot append value, right? And then here's what we need to do. We'll iterate through the array and then take every value and add it back to the end of the array. Well, we'll iterate from this point all the way to 4 without including the item we just added to the array, right? To the list, sorry. So for I in range len of nums minus 1, right? We can do this. We can say so we need to append to this nums, right? The last item. So say nums dot append nums dot pop. You know, pop will mutate the original array, meaning if we pop a value, right, it will remove it from the array. But we are now adding that value back into our nums array here. So we'll say pop at 0, right? Let's see how this will work. So we can do this. So I'm just trying to, you know, I'll not say simulate, but like show what this extend left does, right? Extend left. So extend left will add the value in front of the array. So let's print nums and see what happens. First of all, we need to call the append method. So append to top, and we want to add, say, 5, right? So we want 5 to be in front of the list here. So let me close this, sorry if that was blocking the view. So we can say print nums, right? Yeah, so append to top 5, print nums. Let's see. You can see 5 has been added in front of the array. Oh my god, this is a lot of hello. Nice to have you in the stream. I'm sorry if I'm not responding because I'm explaining the question. So thank you for being here. Is there any function to add at a particular index? Thank you, that's a good question. So I've actually done this now. So we can add, I mean, let's say so this is append to top, right? Let's say we want to add a value at a particular index. So somebody asked that question, and I think I will need to experiment that. So let's try it out. Let's say we want to add a value at a particular index, right? First of all, you know, okay, thank you, Singh. Thank you, Kumar Singh. Yes, thank you very much. You are welcome to the stream. So let's say we want to add a value at a specific index in an array, right? Without even, you know, without even knowing how much items existed in the array, right? Let's say we want to insert, you know, normally what we would do is we can do something like this. We can do append will add an item to the end of the array, right? And you know, that's just it. We can reassign a value at a particular index, but we don't have any built-in function to insert. Let's say we have 1 2 3 4, right? Let's say I put 6 here. 6, and we want to insert 5 between 4 and 6, right? So how do we do that? How can we do that in Python? Well, I don't know if there's any built-in functions for this, but we can actually try to, write our own custom functions to do that. So let's see how we can do that. Sorry, I'm deviating from the actual problem I'm solving, but this is also good to know. So let's see. Yes, looping will increase its time complexity and space complexity. Yeah, so we are definitely increasing the time complexity, because we have to, search for the index at which we want to insert that value, right? So that it will take us O of n time complexity, but in terms of space complexity, it's still going to be constant space, because we are not creating a new array, right? We are simply mutating the existing array. So let's see. I'll write a function here. So let's call this insert insert at index. Insert at index. So we can say our index is going to be, so I'll call this index. This function will take an index parameter. So say index is going to be an integer, and let's just do this. So we can say, so let's say first of all, we need to make sure of two things. We need to make sure that the index we are trying to insert the value at is actually is not larger than the length or the size of our list, and also not smaller than the size of the list. So meaning we need to make sure that when the user inserts -1, right, as the index, we need to prevent them from, because we can't insert a value as -1, right, and we can't insert a value beyond the size of our array. So we'll say if I'm still going to use this num array, you can also add a second parameter for the array you want, or for the list you want the user to use. So let's say the user wants to use a custom list by themselves, so you can add a second parameter here, like this. You can say nums is going to be a list like this. So let's just use this list. Okay, we can say list. Hold on, how do we do this? It's going to be an array. No, we can import list, right? So we can say from, where do we get list from? I think from, hold on, let me see, from typing. Okay, we can use from typing. So let's do this. So from typing import list, right? Import list, and you just set it here, list like this. So we'll say this is going to be our list, and it's going to take integers, right? Now let's write a function. We'll say if index, let's call it idx, because I don't want to type it all, so I'll say index like this. If idx, right, is less than 0, or idx is superior to the length of nums, we can say print out of range. I'll say out of range, right? Out of range. But if the index actually exists, so here's what we need to do. First of all, when we are inserting a value in the array, we increase the size of the array, right? We increase the size of the array. So we need to add an arbitrary value to our list. So we'll say nums dot append 0, right? Don't worry, we will mutate this array at the end of the day. So here's what we need to do. Now we'll have to iterate and shift this 0 up to a point where we will replace it at this particular index, right? So say for I in range, first of all, we are going to start from the last item in the array so that we can target this 0 here and replace it with a new value, right? So we'll replace it with the newest value. So it will be you know, range at length of the list, so length of nums, right? Length of nums. So length of nums is going to be the size of the array, so we have to do length of nums minus 1 so that we can target the last item in the list, and we have to iterate backwards, so minus 1 like this. And here's what we need to do. So we begin to reassign the values. So say nums at this index here at I, right, will become nums at I minus 1. So it will become the previous value, so I minus 1, right? And this way we'll iterate and shift every value, right? So let's say we had I'll quickly write this. So if we added 0 here, right, like this, we'll say nums at I will become nums at I minus 1. I minus 1 will be 6, right? So this will be changed to 6, okay? And then the previous value here, so this will be 6, this will become 4, and you know, and so on, which is what this you know, loop is doing here. So the next thing we need to do is simply replace the value that we want to insert at its own index. So we'll say nums at index, so idx now becomes so we are inserting a value, right? So let's say index and maybe a value that we want to insert. So we'll say value here is also an integer, so we'll say becomes this value here, right? So with this function we can insert a particular value at a specific index in a list or in an array. So let's do that now. I'll say you know, print, you know what, let's not do print. So we can say this function should return the nums, right? So return the list. So I'll say return the list. So return nums. Okay, so let's say new list. I'll call this new list should be equal to insert at index. So first of all, we need the index we want to insert to, and we also need the list, we need the value we want to insert. So let's say this nums array here, right, has 1 2 3 4 6, right? And I want to insert 5 between 4 and 6, right? So here's what I need to do. First of all, I need the index. So at what index do I need to insert 5, right? It's going to be the index before the last value, right? So between 4 and 5. So this is 0 1 2 3 and then 4. So we have 4 items in this array, so it's going to be at index 4. So we want to insert at index 4. So say 4, and what value we want to insert? We want to insert 5. And what is our array? So we'll use the nums like this. Okay, we can use nums directly from here. So let me remove this here, and let's print. You know what, there's something happening here because we are using the same name. Let me just put it here like this. Okay, so that's better. I'll print our new list, and you'll see what will happen here. So let's run this and see. Now you can see so something strange just happened. Let's see, is this function still running? we have 6 in front and 6 behind with 5. So what's going on? Now nothing else is happening, but it's just a bug. So let's see what we can do here. So nums at I minus 1. So we are shifting every value, right? So I mean nums at I minus 1. Oh, you see, we have to stop the iteration at a specific point. It's not -1. We have to iterate up to the last value, right? So here we have to stop at 1. So let's see. Okay, now something else is happening. We have to stop at 0. Okay, hold on. We want to insert 5 between 4 and 6. And here is what is happening. First of all, we know the size of the array will increase, so I added 0, and I started from the last item in the list. So this will be 0. You know what, let me use so 1 2 3. Want to insert 0 1 2 3. So we want 5 to be at this index. So I don't know, this is a bug. Something else needed to happen here. So hold on. I think, let me think. Want to insert the value at this index from this array. Is it because I'm passing the array directly? I'm not sure, but that shouldn't be an issue. 5 is at its correct position, but I'm not sure why, the value of 4 is being changed, right? 4 needed to still be here, right? So what's going on? What is happening? Let me think. So we have 5 4 6. We appended. Let's print nums here. So print nums. We shall have 0 at the end. Okay, so when we have 0 at this position, right, we want to take, oh, you see, here's the mistake I'm making. I'm iterating for, I want to stop at that particular index, so I can do this index here. IDX, sorry, IDX, up to this index and stop there. Okay, now you can see we inserted 5 between 4 and 6, right? So here's how you do it. So you iterate up to the index you want to replace the value at. At this point, the 0 would have moved to that position, right? So before we replace this value, let's see where 0 would be. So we'll say print the nums again. We'll print nums. I'll just add after shifting here. After shifting, okay. So now you can see after shifting, you can see we have 6 twice, right? Which means it's safe for us to replace 6 with the value we want to insert in the array, which is 6. I hope that answered your question. You know what, let me create a file and call these helper functions. I'll just create a folder here. Let's see. Okay, sorry, that's not what I wanted to do. New directory. I'll call this helper functions. right? So these are helper functions. You know what? Let me rename this properly. I want it to be the last value, or at least the first one, helper functions. Yeah. Okay, so this is it here. So it's at the top, and I'll create some functions here. I'll call this insert value at index. Okay. Sorry, I kind of deviated from the whole thing, but this is also good to know. So I'll just copy this. I'll copy this. Oh, I didn't spell insert well. Sorry. That's good. That's good. Um, nice. It's good that you're studying. Singh said, "Why is the timer going down below?" Oh, the timer is for how long I'm streaming, right? It has nothing to do with the question itself. So, uh, don't be bothered about it. Yeah, it's just for me to, track my time spent while streaming. Yes, exactly. Ransom is right. So let's import this theme. Yeah, so insert, oh god, insert, insert here. So insert at index. All right, so we have this here. This has been created. And another helper function I created is append to top, right? So append to the top. So we can append to the top of a list by, I'll just create this here. Call this append dash to top. So we have append to top here. So you can have access to these values. I'll just put nums should be a list. Again, we will need the list from the list of integers. So I'll just put this here. Import this name. Okay. So let me quickly commit these two, and we'll carry on with our question. So just a minute, I'll put a pass here and another. You know what, it doesn't really matter, so we can just let me commit those two. Git add git commit dash the message, I'll say helper functions. So after this, you can have access to the helper functions from GitHub, and you'll be able to use these as well. So let's move on. Let's move back to our question. So we can do something like extend left to add an item to the front of the queue, and then pop left to remove and return the item at the top of the queue or the stack. Sorry. So the next thing is to see the top, right? So we want to see the top of the queue, so we can do something like this. Since the queue is simply a list or an array, we can just get the item at the first index, right? So say return self dot queue at index 0. Okay, so an empty. So if we can say if so say return true, right? If our queue self dot queue so the length of this queue, sorry, if the length of this queue, if length of queue is superior to no if the length of the queue is equal to 0, return true, else return false, right? Like this. So what else is left? reformat the file. I don't know why. Um, okay, so let's test this out in LeetCode and see uh, if this will work. So we can run this now. I hope I still have some time left to, solve some other questions. So let's run this. See whether this works. Okay, our solution has been accepted for the first test case. Let me submit. Impressive, right? So this question is good. We've solved this question. Implement queue using stack. I'm not going to do this. This is a very uh I don't know. I don't want to fall into that trap, but yeah. Somebody said, what resource you use to for learning DSA? Um, LeetCode.io, but I would recommend LeetCode.io. I use so for the past 2 weeks I've not, I mean 2 months now, I think I've not used LeetCode, but Geek for Geeks, right? Whoa, how do you say it? This is Geeks for Geeks. Okay, Geeks for Geeks is actually useful. You can get anything you want here. I promise you anything. And then when you don't understand the question, right, and when you are struggling with a question, just simply look at the solutions here. I always do that. I look at the solution. I look at the solution. You know what? Forget about LeetCode for now, but let me show you a normal way I do this, like how I'll go about this normally. So here's what I do. First of all, I look at the solution if I don't understand the question. So for example, this question here, let's say I do not understand this question. I can come here, right, and look at the solution, try to understand it. You can read through the solution for any question at all, right? Any question. So there are a lot of solutions here. In some cases, the editorial might be available to you, so you can look at the editorial and read. So the best thing is to understand the question, right? Now, let's say you want to learn about arrays or maybe stack, right? So I usually come here. This is the free resource I'm talking about, right? Because LeetCode course is actually paid, but if you want a free way to do this, just come here, right? Read about stacks, If this place, they have a lot of examples. I actually learned about stacks and most of my data structures on this place, right? So if it's not a secret, what is written on the board behind? Oh, okay, this board here. Well, I'll come to that later on. So let me explain to MMD. So I'll come to this part and read about stacks, right? Now I'll take an easy stack question, try to solve it, right? If I encounter an issue or if I have difficulties understanding the question, I'll look at some solutions, right? And try to see how it is solved. Then I can apply that same, method to other questions, and at least you have 50% chance of solving the next question after looking at the question, right? I mean, after looking at some solution, or most importantly, the editorial is useful sometimes. You can read through it and see how the question is solved if you don't understand it, but it's always good to try it out, right? To try it out first and see if you can solve it or not. So you read all these articles. I will say you have to read everything, right? You just have to read enough to understand what you need to know. Yes. So that's like a free way to do this, right? I think there's this website, roadmap.sh. Roadmap also has some nice resources for learning data structures and algorithms. So you can come here, data structures and algorithms, and look through roadmap.sh. So at each point, they usually provide resources, right? If you are using JavaScript. But anyways, let's say linked list. You want to learn about linked list, so you can come here, right? Free code camp. There's a video, but I don't really use roadmap.sh like that. Most of the time, I'm on Geek for Geeks. Geek for Geeks, yes. So that's how I read, or that's how I study. Yes. So, what's behind my board? Oh, you are welcome, MMD. Behind my board is just some, when I'm, working on the project, I can just scribble some things on it. I was actually planning to write stuff on the board while I'm teaching, but I think, uh, you know, there is a bit of uh, stress going to the board and recording from the board. Yeah. So, but it's all in English, and I only know Russian. Oh, so sorry. I actually do not understand Russian. I would have explained in Russian. I can speak French. I actually have some videos in French here. So, but I'm not recording live videos in French. But I can only speak English and French. Yeah. Anyway, you know, Ransom has been coming to my stream all this while, and every other person that has been coming here. I really appreciate you guys a lot. You supported my channel, you helped me grow, which is really incredible. I can't thank you guys enough for your support. Yeah. Yes, so you require a lot of discipline to do stuff like this. Unfortunately, you know, my time is up now. I've spent time explaining the other's question, which is good, right? It's why I'm here. So I have to stream and explain stuff to my understanding, right? How I understand things and share my knowledge with you guys. And if you have any suggestions, you can suggest, right? When I'm solving the question and I did something wrong, you can actually tell me, oh, this is how you're supposed to do it, and I'm open to that, right? And like I said, I'm here to learn and I'm here to share what I know as well. Anyways, thank you guys for being here today. It's been a pleasure studying with you guys. Thank you, Ransom. Thank you. All right. So, don't forget to keep learning. Um, oh, how long have I been learning? Well, okay, a programming language. How long have I been programming? Right. I think close to 3 years now. Yes, 3 years. It's not been very long, but yeah. So it takes a lot of dedication and showing up every day to learn and to improve, to you know every day, every day, every day. Let's. Uh, do I have time to do the next question? Okay, you know what? Let's do it. Let's do it anyway. Let's do it. So I'm going to leave the chat now and solve this question, and I'll be back again. So I still have about 12 minutes or 11 minutes left to do this. So you know what? Let's just do it. Let me just do it, right? Let me just do it. Okay, so here's the question. It says time needed to buy tickets. So the time needed to buy tickets. There are n people in a line queuing to buy tickets where the zeroth element zeroth person is at the front of the line, and the n minus 1th person is at the back of the line. I'm not. Sometimes LEETCODE is just mouthful, and just make some things unnecessary. It does say there's a first person in the at the beginning of the line, right? We know the first person will be at index 0, and the last person will be at the length of the list of people minus 1, right? the size of the array or list minus 1. So you are given a zero index integer array tickets of length n, where the number of tickets in the ith person that the ith person would take. Oh, sorry. You are given a zero index integer array tickets of length n, where the number of tickets that the ith person would like to buy is tickets at I, right? Each person takes exactly 1 second to buy a ticket. A person can buy 1 ticket at a time and has to go back to the end of the line, which happens simultaneously. In order to buy more tickets, okay, if a person does not have tickets left to buy, the person will leave the line. So return the time taken for the person at position K, zeroth index, to finish buying their tickets. So let's say, so here's an example. We have an array of tickets, and these are the amount of tickets each person wants to buy, right? So person at K will be person at index 2. We know our array is indexed from 0, 1 to 2, so this will be this person here. So the output here is 6. So it will take 6 minutes for this person here to buy all the tickets they need, right? So let's copy this, and I'll come here. Let's do this. So we have an array of tickets. So we have first person wants 2 tickets, the second person 3, and then we have 2, and our K here is equal to 2. So what the question says is, when all of these people are in a queue, right? So, and they want to buy a certain amount of tickets, which is represented by these numbers here, right? So the first person wants to buy 2 tickets, the second person wants to buy 3, and the third person wants to buy 2. So each person has to buy 1 ticket at a time, right? So the first person here, once they buy their tickets, right, they'll go back in line for the next amount of tickets they need. So let's quickly simulate this. So we have 3 people in line. So I'll just do this one. Okay, that's a big head. Nobody has that big head. Okay, so 2 like this. All right. We have this person wants 2 tickets, this person wants 3, and this person wants 4. Oh, sorry, 2 as well. 2. Okay, since this person is the first person in the queue, they get served first, right? But they can only buy 1 ticket at a time. So meaning, after being served, the number of tickets left for them to buy will be 1, right? So we'll go here, 1. Right, and it takes exactly 1 second to serve somebody. So I will write out, after they bought their first ticket, this will be reduced by 1, right? You know what? I'll do the reduction when they reach the end of their of the line. So let's put this 1 here, and say this will be. So it took them 1 second. So I'll put 1 here, and this person will move back in the queue, right? So they go back in the queue. I will adjust the queue again. So this person here will get served. So let's remove this 3 and replace it with 1. Okay. You know what? After they get served, right? This person, after they got served, their ticket will be reduced by 1. So they only need 1 ticket left. And this person, after they get served, right, their ticket will be reduced to 2. And it takes exactly 1 second to serve them as well. So far we'll have, let me put this here, we'll have 1 more second gone. So 2 seconds so far, right? Now this is the person we are targeting, this person here. I'll represent them with a blue color so that we know when they've gotten all the tickets they wanted. So we'll say here, right? Okay, so this person will move back in queue. So go back in the queue like this, and then now this person will get served. This is their turn to get served. So we'll put this here. we'll change this to 1, right? They got served. This will be 1. I'll use the same color 1, and it takes exactly 1 second to serve them. So they'll go back in queue again. Oh, okay. That's forgotten their head spirits. Oh my God, what have I done? So now this person here, right, is the next in line to get served. So once this person gets served, right, they will not have any receipts left to buy. So it takes exactly 1 second to serve them as well. So now this is 4 seconds that have elapsed so far. So let's move this back in the queue. So now this person is done, right? There's no need for this person to go back in the queue. So they gets removed. So you walk away, and it's gone. So now this is the next person in queue. So this person will get served as well. So let's remove this. So after serving this person, the result here will become 1, and this will be increased by 1. So we'll count another 1, and this person has to go back in queue again. So they are back in their queue, and here this is our target, right? Our kth person. So the second person, so once they get served, this will be 0, and after service this will be increased by 1. So let's just move here. This person is gone. Now the question is asking us to return the time taken to serve. Let me close this. The time taken, right, to serve the person at index K. So the person at index K just left the queue, right, which means they got all the ticket they needed. So sorry. So here's what we'll return at the end of the day. This count that we made here. So we counted 1, 2, 3, 4. This is 4, 5, 6. So our result here, right, will be 6. So we'll have to return 6 at the end of the day. So all we needed to do to solve this question is we can run a loop, right? And as long as that loop is running, we'll reduce the value of this person's tickets, right, every time in every iteration. So yeah, I'll provide the solution for that tomorrow. I'm late now. My time is done. It's just 2 minutes left for me to end the stream, and I can't write all of that in 2 minutes. So let me submit this code to GitHub. Let me push to GitHub. So I'll push this to GitHub so I can have access to the solutions here. So okay, we need this. So say git, not got, it's git.add git commit dash I'll say this is a queues question, so queues and leet dash 225 git push origin main. So the code for this is on GitHub, and you can have access to it to see the solution and try it out yourself. That's this question here. And I also created some helper function, which is the insertion at a specific index and insertion to the top of a list. All right. Thank you for watching. Thank you for staying throughout the stream, and I will see you tomorrow.